Okay, ladies and gentlemen, let's take a look at quadratic application problems practice sheet. The following is a time-lapse video that shows a snowboarder doing a trick. Very, very cool. So, where would you put your axes? I think I would put my axes something like this. I would have my axis come down here, and I would come out this way. And let's see what they have to say here. The height of the snowboarder above the ground. So this is the height above the ground. And what do we have out here? This is the distance from the start of the trick. So distance from start. It could have been time, right? It certainly could have been time. In this case, it's distance, whatever. And this is from the start of the jump in feet. So, which of the following equations could be a correct equation from the graph? And again, we're looking for which one could be correct, not which one is correct. A couple of things to notice here. I seem to have what I would consider a vertex happening about here. So, and that vertex, the way I have it set up with this axis, this would definitely be a positive x, and this would be a positive y. So I'm looking for an x comma y that are both positive. So going through the list, this has a vertex of negative 10 comma 8, so no. This one has a vertex of negative 10 comma 8, so again, so no. Because the way I've set it up, negative 8 comma 10 is over here on the axis, not on this side. It would be in the opposite direction of the jump, so that would be a bad idea. So this one works and this one works in terms of my vertex. Now, that's a parabola that is definitely opening down. So this one's opening up, and that's a no. Okay, so the only one that could be correct, now I'm not saying it is correct, I don't know if it is or not, but it's the only one that has any chance of being correct. So that's going to be the one. They would like me to explain my reasoning. I think I did. This would be in a different quadrant. Or you could simply say this vertex, it has a positive x, a positive y, and this one's giving a negative x, a positive y. No. And that's good enough for me. Some of you out there will give me more explanation, which is lovely. Some of you will try to give me less, which is not lovely. This is the bare minimum to get away with. I have a question. Yes?
I got that wrong because I thought the star was on the right.
What did you think?
I thought the jumper was starting from the right going to the left.
Oh, going this way.
Yeah, so that's what it looked like.
You know what? I agree.
So I had the third one when I forgot it.
Not being a snowboarder and being a man with glasses and a little bit old, it looks to me that perhaps he could be going this way. In fact, his eyes seem to be going this way, don't they? So I will agree with you. I will absolutely change my answer. And I would say he should be going that way. Which means that this will be positive and this will be positive still. Which, now hold on. This positive, this positive. So if that's the case, if he's going this way, and if I make this the positive x-axis, and if I make this the negative x-axis, then our correct answer would in fact be a negative x and a positive y, which means that we would be interested in either this one or this one. Hold on. This one or this one. So that would be out of the running. That would be out of the running. And we would want the one that opens down. So this, in fact, would be your correct answer if you went the other way. Is that what you came up with?
Yeah.
Ladies and gentlemen, I am not going to change this video because it shows that I am wrong and you guys are absolutely right. And that should be the answer. So looking at the eyes, he's going this way, and it should be that. I promise that when I give you a question, I will try to make it very clear. which way is which way, okay? But that's excellent. Very good. All right then. Thank you for that. Next. Tarzan. Tarzan is swinging along the treetops. Good old Tarzan. Do you guys know who Tarzan is, or is that old? Were you guys around for the TV show, Tarzan in the Jungle? George of the Jungle. George of the Jungle, strong as he can be. Okay. So instead of Tarzan, you can think of it's George. Here's George flying through the jungle. X is the distance away from Tarzan's hut. You gotta read the questions. So this is distance from hut. And this is going to be height above the ground. Okay, so state the transformations. Well, how many transformations do you see? I hope you see two of them. Hope you see a horizontal shift, and I hope you see a vertical shift. And that's it. No stretches, no compressions, no reflections. So, and it doesn't matter which one you give me first. So horizontal, shift, right, 4. Do you notice that I'm not putting in the whole word for horizontal? Do you notice that I'm not putting in the word units? We know what we're doing now, right? So we can start making it a little bit easier on ourselves. And this will be a vertical, shift, up, 4. Step pattern. As I said, there's no A value here. Well, there is an A value. There's an invisible 1. But that doesn't allow for a stretch or a compression, does it? So if A equals 1, the step pattern stays the same. It's congruent, the same shape as y equals x squared. So it is over x from the vertex. We have to remember that. Over x from the vertex, up x squared from the vertex. And let's just make that absolutely clear that this is always from the vertex. It's not a slope. Slopes are constant throughout an entire line. The step pattern depends on starting at the vertex. Graph the quadratic using functions. Okay. So where is this lovely vertex? You should be able to tell me that that vertex is 4, 4. So I'm going to come out 4 and I'm going to go up 4. And there should be no discussions about that. That should just be what we can do. Easy peasy lemon squeezy. So that's our vertex 4, 4. I came out 4 in the x, I went up 4 in the y. Now, step pattern, over 1, up x squared. So, over 1, up 1, over 1, up 1. Over 2, up 4. 1, 2, 3, 4. 1, 2, 3, 4. Over 3, up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Notice that you're going up from the vertex. Oops. Over 1. Okay, so now, lots of kids are going to do this. And you're going to stop there. Not a good idea. I need that y-axis. I need the y-intercept. It's important to the graph. So we need this point over here. So you have a couple of choices. Here's one choice. Over 1, over 2, over 3, over 4 from the vertex. So I'm going to go up 16. Now remember, this is 4, 4. So if I go up 16 from 4, 4, that means I'm going up to 0, 20. That's a fast way to do it. Not a bad idea. Come over here, put the other point on, and now I have a parabola that gives me most of the important information. Okay? And that's the minimum I'm going to want to see. There's another way to get this 20. Let's look at this equation. Y equals x minus 4 squared plus 4. You know for a y-intercept, or at least you should know for a y-intercept, that x is always 0. So this is what we're after. So that's why you see me sometimes say set x equals to 0. What that means is you get 0 minus 4 plus 4. Minus 4 squared is 16. Almost. Plus 4 is 20, which means that the y-intercept is 0, 20, which is what we had here. Your choice how you do it. In fact, you should be able to do both. Okay, yay. On the graph, show where ground is located. Ground. On the graph, show where Tarzan's hut's located. Well, the hut better be on the ground, and notice that this is the distance from the hut. So that means that the distance from the hut better be 0 when you're at the hut. That just kind of makes sense to me. Tarzan swings to another platform that is the same height as his hut. Show where his platform is located. Okay, so the hut is not on the ground. Let's be very, very clear here. I made a mistake right there. The hut's not on the ground. The hut is built in the tree. How do I know? Because this is the distance from the hut, and the hut is located 20 meters above the ground. So his hut's in the tree. Now, he's going to swing to another platform that's at the same height. Well, the same height is going to occur right here. So, show where this platform's located on the graph. So this is other platform. I'm looking out at the studio audience and I see them putting in some things, so this is good. Okay, what's next? Highlight the part of the graph that represents Tarzan's actual swing. So Tarzan's standing here. If I had to draw a picture, good little Tarzan's here. And he swings, and he falls. Whee! And luckily for him, he goes back up, whee, to the platform. There's Tarzan. How close does Tarzan get to the ground at his lowest point? Well, that's going to be his lowest point to the ground. And I believe that is 4 meters above the ground. Oh, wait. I'm sorry. I goofed. I highlighted 4 meters. Okay. How high above the ground is Tarzan's hut? 20 meters. If there's a 10-meter tall tree that's 6 meters away from Tarzan's hut, so 6 meters away, up to 10 meters. Okay, so we got a tree there. Show where the tree is located on the graph. We got a tree here. It's probably not a fir tree, but you know. Tarzan gonna hit the tree? Oh yeah. Georgia the jungle, dunk. He hits the tree. He's gonna come down and whack. And why does he hit the tree? Because the tree is taller than Tarzan will be at 6 meters. Is that a good reason? Because Tarzan is going to be at tree height at 6. I don't care how you say this, but the bottom line is the tree's taller than Tarzan is at, you need that word, at 6 meters away from his hut. So the tree is higher than Tarzan when he is 6 meters from his hut on this swing. And what I mean by swing is grabbed on and went for a swing. Okay, I'm going to pause the video here and we'll be right back.